Hi students, in this section we discuss successive division. Now what do we mean with successive division? Let me take an example to explain that. Say I divide 10 with 3. So I get a quotient of 3 and I get a remainder of 1, right? Now I take the quotient and I write it over here and I divide the quotient, say for example with 2. Now it goes once and I get a remainder of 1. So this is what we mean with successively dividing 10 with 3 and then with 2. Alright, now let's try to do this question to understand how to tackle this type of problems. The question reads, if a number is successively divided by 4, 5 and 7, the remainder obtained are 2, 3 and 1 respectively. What will be the remainder if 6 divides the same number? Pause the video, give it a try and then we'll do it together. Alright, I hope you have given it a try. Let's do it together. I write the divisors over here, that's 4, 5 and 7. And let me write the remainders obtained over here, that's 2, 3 and 1. Now, I represent multiplication with the orange color and addition with the green color. To get the answer, I have to multiply 1 with 5, add 3 to that, multiply the result with 4 and add 2 to that. So what do I mean with that? Let me write the expression over here. Alright, so my innermost expression is 1 into 5, that's multiplying 1 and 5. I add 3 to it and to the result, I do the operation of multiplying by 4 and then I add 2. So this becomes 8 into 4 plus 2, which is 34. Alright, let's check whether 34 satisfies the given condition. I write my quotients over here and remainder over here. I start with 34 divided by 4. That gives me a quotient of 8, right? 8 into 4 is 32 and a remainder of 2. That's satisfied, right? I'm getting a remainder of 2 over here. Now, let me take the quotient, that's 8, and divide it with 5. 8 divided by 5 gives a quotient of 1 and a remainder of 3. That's what we wanted over here. Now I take the quotient, that's 1, and I divide it with 7. It goes 0 times and I get a remainder of 1. That's what we had over here. So we can see that 34 satisfies the conditions given in the question. Now, is 34 the only number that will satisfy this? No. There are infinite number of numbers that will satisfy the given condition, and the numbers will be in the arithmetic progression of 34 plus 4 into 5 into 7 k. And remember, these 4 and 5 and 7 are the divisors, right? So you just need to multiply the divisors and you will get the common difference of this arithmetic progression. So what would be the next number? So when k is 0, you get 34. We've got that over here. When k is 1, that would be 34 plus 140, which is equal to 174. Now let's check for 174 if the condition is met. Let me do 174 divided by 4. That goes 43 times and I get a remainder of 2, right? That's what we wanted over here. Now let me take 43 and divide it with 5. That goes 8 times and I get a remainder of 3. That's what we wanted over here. I take 8, which is the quotient, and divide it with 7. It goes once and I get a remainder of 1. Therefore, we can see that the given condition is satisfied, right? So every number of the form 34 plus 4 into 5 into 7k will satisfy the given condition, and 4 into 5 into 7 is 140. So it's 34 plus 140k. Alright, let's keep that aside. Now let's try to solve the question. The question says what will be the remainder if 6 divides the same number, right? So if 6 divides this numbers over here, what's the remainder? 6 is not a factor of the common difference, right? So let me write that over here. 6 is not a factor of 140. So the answer to this question is it cannot be determined. Why is that so? Let's see why that is. 34 divided by 6 will give me a remainder of 4, right? Why? Because 6 into 5 is 30 and 30 plus 4 gives me 34. So over here I'm getting a remainder of 4. Now we have seen that the next higher number that satisfies the given condition is 174. Let me do 174 divided by 6. That gives me a remainder of 0, right? 174 is divisible by 2 and 174 is divisible by 3, right? Because the digit sum over here is 7 plus 4 is 11 plus 1 is 12, and 12 is divisible by 3. Therefore 174 is also divisible by 3. and hence 174 by 6 gives you a remainder of 0, and you can see that these two reminders are not the same. Therefore the answer is it cannot be determined. Now if instead of 6, if the question was asking 4, what's the remainder if 4 divides the same number, you can see 4 is a factor of 140, and in that case the answer would have been 34 divided by 4, which gives you a remainder of 2, because 8 into 4 is 32 and 32 plus 2 is 34. Hi students, let's try to do this question. If a number is successively divided by 2, 4 and 3, the remainder obtained are 5, 2 and 3. What will be the remainder if 6 divides the same number? The second question is, what will be the remainder if 7 divides the same number? Alright, pause the video, give it a try, and then let's do it together. Alright, I hope you have given it a try. Let's do it together. We have seen that I can write the divisors on top and the remainders on bottom, and my answer would be 4 into 3 plus 2 into 2 plus 5, right? That's what we have seen. 4 into 3 is 12, 12 plus 2 is 14, 14 into 2 is 28, 28 plus 5 is 33. Now I can write the generic expression that satisfies the condition given as 33 plus 2 into 4 into 3k. Remember, 2, 4 and 3 are the divisors. Now this is equal to 33 plus 24k. This is the generic expression that satisfies the given condition. Now let's do the first question. It's mentioned what is the remainder if 6 divides the same number, right? And we have seen it's not only one number that satisfies this condition, it's an infinite set of numbers that follow this arithmetic progression. Now you can see that 6 is a factor of the common difference of this arithmetic progression. What's the common difference? It's 24, right? 24 is the common difference. Let me write that over here of the AP, right? Now we know that if any term of the arithmetic progression is divided by the common difference or a factor of the common difference, the remainder will always be the same. So what's the first term of this AP? It's 33, right? The second term would be 33 plus 24. That's equal to 57, right? Now let's try dividing 33 and 57 with 6, and let's see what's the remainder. 33 by 6 gives you a remainder of 3, because 33 is equal to 30 plus 3 and 30 is 6 into 5. Similarly, 57 by 6 also gives you a remainder of 3. Therefore, we see that the answer for the first question is 3. Now this next question is, what's the remainder if the number is divided by 7? The answer will be, it cannot be determined. Why is that so? That's because 7 is not a factor of 24, right? And what is the implication of that? 33 divided by 7 and 57 divided by 7 will not have the same remainder. What's 33 divided by 7? What's the remainder? That's 5. And what's 57 divided by 7? The remainder, that's 1. And you can see 5 is not equal to 1. Therefore, in the second case, the answer is it cannot be found.